Hello everyone, welcome back to Day One Dev YouTube channel. Today we're going to talk about event-driven architecture pattern. Uh, so let's start with it, and I hope you learned pretty good key features when I'm transitioning from a messaging platform to a streaming platform, right? So event-driven architecture pattern is a distributed asynchronous architecture pattern used to produce highly scalable applications. It's also highly adaptable and can also be used for small applications as well as large complex one. Right? So the event architecture is made for highly decoupled single purpose event processing components that asynchronously receive and process events. So now it also consists of two main topologies, the mediator and the broker. So the mediator topology is commonly used when we need to orchestrate multiple steps within an event through a central mediator. Whereas a broker topology is used when when we want to chain events together without the use of a central mediator. The architecture is characteristics and implementation strategies differ between these two topologies, but it is important to understand each one of uh, the methodologies uh, want to know which is the best suited for your particular problem solving. Right? So let's jump on our big picture of architecture, how it's going to be. So here, if you see that in architecture, there are two main components keeping a Kafka cluster where you can have a number of topics here, 1, 2, 3 to n, and similarly partition. You'll have another partition, which it depends on your cluster size. You can have a number of partitions. Right? So there are two connectors. One is a sink, the other one is a source. I'll talk about them, each of them, the details also. So sink connector ingests entire databases, stream tables, updates to a Kafka topics, right? So the source connectors can also collect the metrics from all your application servers as well as streaming process with a low latency. So sync connectors deliver data from Kafka topics to secondary indexes, such as the files, databases. I think I did not called out exclusively here. Elasticsearch is part of an SaaS or batch systems where the batch systems can be driving your microservices as part of a batch services. Or also you can put it under Hadoop, which are categorized as part of a databases. Okay. So the event-driven architecture, as we discussed in our previous video, has several advantages within uh, and especially key features also. I want you to, if you haven't seen that, I highly recommend go back and look at my other video where I talked about streaming platform key features. Okay, so now let's talk about several key advantages here. So one of them is asynchronous, which is event-based architecture, or asynchronous without blocking in the threads. Right? So this also helps you to move your resources freely between your tasks uh, and helping you to move faster, as well as you're not uh, waiting for your events to be queued or buffered, which prevents consumers from putting back your pressure, or producers are blocking them. Okay? And they are loosely coupled services don't need to or should have to wait or knowledge of other dependencies or other services. When you're using the events, services operates immediately details and transport protocol. So the other one is easy scalable. So if you are since the services are decoupled under an event-driven architecture, typically perform only one task, tracking down bottlenecks to a specific services, and scaling the services becomes easy. And recovering support is also another one, which is event-driven architectures are with a queue can recover lost work, replaying events from the past. So one of our example I can give you the is Uber, where you're posting messages, and once a driver, consumer, or the user who's looking for a driver, they're posting a message saying that I need a driver from point A to point B. And once the driver gets a notification, they can see a message, multiple drivers who are available in that area. They see that message. And once the driver is acknowledged, that filter has been logged, and using one of our connector, you can go back and you can update your message stating that the driver has been acknowledged and he's picking up that passenger or to driving point A to point B. So that's a one of our example, but still the message can be living in your one of your partition for X number of days. Okay, you can set that in your streaming platform. The message can be here, but it has been makes a notification of a processed. The message can live somewhere between in minute or maybe an hour or 24 hours to a 31 days. And also you can, it's not a mandatory, it will expire in 31 days. It's your data storage. You can store the data a number of days. So keeping aside, the event-driven architectures also have some drawbacks that are easy over engineering by separating concerns that might be as simpler when closely coupled. So, and also often results additional complexity in infrastructure, right? So perhaps most of our significant drawbacks and challenges in data and transaction management because they are asynchronous nature. Event-driven model must carefully handle inconsistent data between services and incompatible versions. Right? So watch for duplicate events and typically do not support asset transactions instead of supporting eventual consistency, right? Which can also be more difficult to track and debug. So even with this drawbacks, an event-driven architecture is usually a better choice for enterprise level microservices applications or systems. So the pros are scalable, loosely coupled, and DevOps friendly. That's one of a big one. And design when you're designing compared to your cons, I see more pros here. Right? So if you see here another scenario, just want to bring it up. The sync connectors are good if you're having a small processing logic, but it should be try to keep your not too complex logics here in connectors. These are good picking up a data, any changes happening directly, they can pick it up data and they can write it to cluster or your partition. Similarly, they also can read and write it to cluster. So they can do both ways, sync connectors and source connectors. There are one of a good example I can give you is Salesforce. If you have a Salesforce here, Salesforce directly, instead of you're making their API calls, you can use connector. Any event has been happened on a Salesforce. The Salesforce can draw using a connector. They can drop to a message here, and your internal applications, you can directly using a sync connector. You can post that data to internal database, or you can put it in your file system, right? Or it can make another call to your other SaaS application if they have a connector. If they do not have a connector, there's other alternative approaches. You can go through a microservices where you can read your cluster from your partition data, and you can call kind of API, post that data to your SaaS providers or other places like a queues, email notifications, or whatever you want to do it. So the one part which I want to highlight here is the green color I called out here in both the places. These are the legends. I want you to look at it. The authentication, you have to be very careful. Authentication should be SSL based if you're using it on Kafka cluster, and highly recommended to be on content types is one of the two which I listed here, Avro and JSON or application formats. So so keep that in a, you can also use, it's not required you have to stick to only these two contents, but Kafka cluster, you're taking advantage of the features if you're sticking to that one of the two content types, right? So now we are pretty close to our architecture part getting on. So let's see some of our references here I want to provide you. Coming to a streaming security, I do recommend look at a Confluent project. Confluent is the commercial version of Kafka. They use Apache Kafka and they provide a support. So some of our regulatory supported organizations or enterprises, they cannot directly deploy using a Kafka, downloading a Kafka from Apache site, and they cannot deploy it. So they need some support for to run in the production. So Confluent is one of a provider who provides Kafka support, especially I was not aware any other providers in the market, but at least I know Confluent. So Confluent, look at this documentation which I provided here, streaming, the developer guide and the security. The connectors related information I did provided Apache Kafka Confluent connector configurations, how to do it. And this document also has, if you want to write your own connector, it has some examples where you can build your own custom connectors if you have a custom system which cannot follow standard connectors. And finally, the current connect service which I was calling out here. Look at here, there's all the sync and source connectors are available here. And if you are looking for learning about most of our connectors, the 100 day of a code developer content has a lot of learnings where you can go, you can learn from here. All right. I hope you learned something new about a connector when as an architecture, if I'm trying to do some architecture, so enterprise level architecture, I do document kind of a more architecture diagram the way I provided. If you're looking for some deep dive, how the cluster will be like infrastructure level, then application level, please comment on my section. Definitely, I'll provide you some examples and how to do your maybe a Terraform scripts if you're more Terraform oriented organization. All right. Thank you very much and have a wonderful day, and I'll see you in the next video.